This is a robotic arm. I like to call it Mark 1.
It's an Arduino powered robotic arm, which features a claw for moving objects around, as well as 6 motors for better movement. And this robot can be programmed with an Arduino, which means we can automate our favorite tasks, like passing verification tests. In this example, it's able to pass capture forms. Or it can even automate tasks like picking up objects. Now, how it works is that each of these motors are all working together to complete a task. But there's more. This prototype can be controlled by hand gestures, which means we can have a more natural interaction when controlling the robot, moving any part of the robot. And since it's wireless and portable, this means we can control it whether we're next to it or at a range, completing tasks without the need to program every step. And this is going to be the first prototype for the project.
And honestly, there's quite a bit we can do with this. And staying true to the Iron Man theme, we're calling this prototype Mark 1. And in this video, we're going to find out how to build a robot arm as well as a robotic glove. This video has been timestamped so you can go to different sections, as well as you can find a 3D model, the code and the part list in the description below, which will go into more detail. Before we start, if you like this type of content, help us beat the YouTube algorithm by smashing the like button, and also leave a comment. I literally reply to every comment, even if the comment is comment. Consider subscribing and turning post notifications on. We got more videos on the way. Isn't that right, Mark? Mark? And if you stick to the end, you also find out how well this robot works. Anyways, that's enough from me, and let's start building.
The part list. Now, in order to put the robotic arm together, we'll need an Arduino. This will pretty much be the brains of the robotic arm. We'll also need 6 servo motors. The servos will be used as joints for the robotic arm. A stepper motor, a servo driver, a battery for the servo driver, a Bluetooth module to communicate with the robotic glove, some jumper wires, and a breadboard. And for the robotic glove, what we'll need is an Arduino. This time we're using a smaller Arduino Nano, a breadboard, a flex sensor, an accelerometer. Now these two will make up the sensors for the glove. And lastly, a Bluetooth module in order to communicate with the robotic arm. Links to the parts are in the description below. So, how does it work? Here's the joints that make up the robotic arm. Now, we can think of the robotic arm as a series of motors, all working together to complete a task, like moving an object. Here's a closer look with each motor rotating on an axis. We're using the Arduino to control the servo motors, and to drive them all, we'll be using a driver. And each servo motor would be programmed to move together to perform a task, like picking an object. And then we can assemble each servo motor into a 3D printed robotic arm. And program it. And this is pretty much what we'll be building. But the question is, how do we communicate with the robotic arm? Using hand gestures from the glove. So when it's all stripped down, we've pretty much got a sender and a receiver. And we're using a sensor to send values to the robotic arm to move the servos. And this is done over Bluetooth. So having a closer look, where we bend the sensor, the value changes. Now if we exceed a specific value, we can send a message over the Bluetooth to turn that specific servo motor. So in that case, when we bend our finger, we can in turn control the robotic arm. We're also going to cover how the 3D arm is printed and adding more flex sensors to make a complete robotic glove later on. But let's get back to the robot and let's get started. Assembly of parts, the robotic arm. Now, there's different examples of robotic arms online. You can either buy one or 3D print one. But since I'll make another version, this one was 3D printed. And if you got a 3D printer, you can find many good examples of free robotic arms to build. This is the one I'll model mine after, and credit goes to this maker. And you can find more instructions on the assembly on the article in the description below. So this robotic arm was slightly modified so we can add a hole for an LED for the gripper part of the motor. Now 3D printing the robotic arm was pretty long, and if you want, you can get an out-of-the-box robotic arm instead. But taking the 3D printing approach helps create custom parts like this. And we can print the other parts. Now that they're all printed, we can now assemble it all together with the servo motors. These can be simply screwed in using machine screws. And it will be mounted in just like this. And now we can slowly assemble the arm, with each of the 6 motors playing a part in the robotic arm build. And these are the parts that make up the robotic arm once we fully assemble it. And here, we're just assembling the gripper part / claw to the stem of the robotic arm. Now, the good thing about the robotic arm is that it has ball bearings, so we can smoothly rotate left or right. The 2 main parts are the base rotation and the robotic arm itself. And now that we almost assemble it, all we need to do is insert these 2 together and lock it in place. And that's it for the assembly. Each of the 6 servo motors have now been mounted in place. And each of these motors can now be programmed to move or perform a task, like picking an object. If you've got any other ideas, let me know in the comments below. Now the robotic arm is assembled, we can see the individual parts these motors play in the rotation and movement of the robotic arm. For example, we can rotate the shoulder joint, as well as extending the elbow joint. And we can even rotate the wrist joint, which will be the claw. Servo motor wiring. Introducing the Arduino. Now we have the servo motors all assembled into the robotic arm. We'll still need to somehow power the servo motors. And in order to power each individual servo motor, we'll need a driver. And this is where the Arduino comes into the picture. Now Arduinos are open source, so there's different copies. We'll be also using a servo driver. And the servo driver we'll be using to do this is the PCA9685. And this is pretty much what we'll need to power the 6 servo motors, which include jumper wires, a breadboard, and a 5V RC battery pack. Now we can slowly assemble these all together. Now attaching the servo motors is as simple as plugging them into their color coded pins. Now we can add the other 5 in. And all of these all attach to the individual motors of the robotic arm, which can drive any individual servo motor on the arm. And we can pretty much wire them all together based on the diagram provided. And now we can add the 5V RC battery pack to the servo driver to power the servo motors. And we can do this by screwing these in. We can now hook up the Arduino to our laptop and load the code to power the servo motors. And you can find all the codes in the description with each test code. In this example, we're just testing the servo motors for the claw/gripper. Now we have the 6 servo motors working, we have one more thing to do. We still need to figure a way to make the robotic arm rotate left or right. Now, the robotic arm is gaining a bit of weight, and using a standard servo motor isn't powerful enough to move it. So instead of using a standard servo motor, we're going to use a stepper motor, which is pretty accurate, as we can control the number of steps/rotations needed. Now, this is the diagram that shows the setup using the stepper motor and the driver. The stepper motor comes with its own driver, being the A4988 driver. And now, based on the diagram, we're just going to assemble it all together. The stepper motor requires a higher voltage compared to a servo motor, so we're going to use an 11.1 volt LiPo battery to supply the power. And loading the test code, we can see it rotate clockwise. We can even smoothen the stepper motor movements by adding a capacitor. So an overview. We went from adding the 6 servo motors to adding the stepper motor, and now this is the full robotic arm electronic diagram. And now we're happy with it, we can mount the stepper motor into the base of the robotic arm, which we can line up and eventually screw in. The stepper motor will be mounted to a gear tooth, which would in turn rotate the whole robotic arm. And as you can see, we got the smaller gear tooth and the larger one in the back. And we can place these two in, and they're locked in place. You can also see that the ball bearings provide for a smoother contact, also reducing the noise. And now we've got the robotic arm all assembled, we can load in the test code to rotate the robotic arm. And that's pretty much it for the robotic arm. And if it's the robotic arm you wanted to do, you can pretty much stop here. The next part will be on how the glove is assembled. Assembly of parts, the robotic glove. Now, staying true to the aesthetics, the robotic glove was also 3D printed, but you can use a standard glove to work with, which I used with earlier versions. Now, the glove comes in parts which can be printed off individually. In this example, I'm printing off the index finger of the robotic glove, which comes in 3 segments. The 3 parts representing the finger joints can all be snapped in. And once all assembled, it fits perfectly on my finger. And there we have it, that's the finger joint. And this is how it looks when it's all assembled. Now, the glove provides a good degree of freedom, which is a bonus. So now that's done, let's find out how the robotic glove sensors work. And from the part list, we'll need an Arduino Nano. This will be ideal since it's small enough to fit on our hand. Also, a breadboard for prototyping, and an accelerometer to measure the changes in the hand movement, and some jumper wires, and the flex sensor. These 2 types of sensors will be the main focus. And lastly, a 10 kilo resistor for the flex sensor. To start off, The following wiring would focus on the flex sensors, with the output of the flex sensor going to analog 3 on the Arduino. And once that's wired up and the code has been uploaded, which you can find in the description, we can test it out. Now the flex sensor works a bit like a potential divider, and as the flex sensor bends, the resistance changes. And here's a graphical look of the flex sensor value changing. Now put in a threshold at, let's say, 70. If it passes this, we'll send a value to the Robotic Arm's Arduino through Bluetooth. And by holding the flex in place, we can also hold the position of the servo motor, and in turn, the robot. And by taking this idea and attaching it to our finger, there we have it. We have a sensor that can detect the changes in our finger movement. Now, the accelerometer would be used to measure the changes in our hand movement. And this is the diagram with the updated accelerometer in place. And now we can upload the accelerometer test code. And by moving it slightly, we can see how the X and Y coordinates change based on the relative position of the accelerometer, moving left to right, up and down. And that's pretty much it, what we'll need and how it's assembled. With the two sensors alone, we can control the robotic arm's gripper to open and close, and as well as rotating the gripper counterclockwise or clockwise, as well as up and down. Now this idea will form the basis of the 3D glove. And for this, I've pretty much added 2 extra flex sensors and another accelerometer, which can be powered from a 9-volt battery. Adding additional sensors, this is what the electronics looks like, with a Bluetooth module to communicate with the robotic arm. Now the next step is attaching the electronics to the robotic glove, going from this to this, where we can bend the flex sensors, which are mapped to each finger. And the most important thing about the assembly is securing all sensors in place. And to do this, we can use hot glue. And this is how we're going to wear the glove. Given that all sensors are now being added, we can now go into more detail on how every flex sensor maps onto the arm. You can see how each sensor represents a servo on the robotic arm. Now this is optional, but you can even add the second accelerometer to an armband, as well as a 9-volt battery, which was added to make the robotic glove portable. And this is pretty much the robotic arm prototype on a breadboard. We'll see how we can make this more advanced. Now, believe it or not, the robotic glove required me to isolate some of my joint movements to not trigger any false positives, and this is where body isolation became useful. Here it is all assembled. And finally, the build. This is what each part does. So opening and closing the robotic claw can be done by moving our index finger up or down, and rotating counterclockwise or clockwise will move the grip ahead, as well as up and down. And we can rotate the whole robotic arm left or right, or bend or stretch to move the robotic elbow. Now that is the robotic glove and arm pretty much done. Now let's get back to the code to see how the programming really works. Now the programming part is explained in more detail on the article in the description below, but it's still important to go over the key parts. Ideally there are 2 main codes, one for the robot arm and the other for the glove, being the controller in this case. So let's start off with the robot arm and see how this will be programmed. To start off, the robot arm includes the servo driver library, being the PC9685. This way we can power multiple servos, all controlled by an Arduino. This will be used rather than using the standard servo.write function. The following here declares and initializes the variables for the stepper motor. And in the setup, we can declare the pins used for the servo and stepper motor. In the loop section, I've added a delay of 3 seconds on startup, so the robot doesn't jump at you straight away. Now, the way we control the servo motors is by using the library name .servo. This takes 2 parameters, the position of the servo plugged on the driver, starting from 0, and the position we'll like to move it. In this case, we'll be moving the servo on channel 3 to the relative position of 10. Now with that theory, we can pretty much make a function that can move the wrist part of the robotic arm, as seen here. And from there you can make other functions like opening and closing the claw and making the robot stand. And that's pretty much it for the robotic arm alone. But if you would like to take it one step further and control the robotic arm with the robot glove, here's the code. Now for the robotic glove, as mentioned, we have 3 flex sensors and 2 accelerometers, and these are initialized here. We'll first off declare the 3 sensors on the thumb, pinky and middle, as well as the accelerators. In the setup, we'll begin the transmission of the sensors, including the Bluetooth serial communication at the baud rate of 4800. Now in the loop section, we'll read the values of the flex sensors to the Arduino. And based on the previous theory, when the value of the flex sensor bends exceeds the threshold, this is when we'll send the character F. And this value is what will be sent through Bluetooth to the robotic arm. And if we go back to the robotic arm code, we can create a function that listens on the baud rate of 4800 with the Bluetooth module. And if it receives the character F, this would then call on the gripper servo backward function, which will move the servo. And this is an indefinite loop, always waiting for a communication from the glove to the robotic arm. And we have an example function here, whereby we're moving the servo on the 5th channel of the servo driver. And we can create as many functions here. And that's pretty much it for the programming. It's now time to put everything all together. Now putting it together, a 3D printed enclosure was used to encase the circuitry of the robotic arm, as well as some braided cables for protection. And now we can finally place all our circuitry into the enclosure. And we can use a simple power bank to power the Arduino. And this is it. This is absolutely everything we'll need in terms of hardware to work with this robotic arm prototype. Now, let's test it out. In this example, we have the robotic arm waking up. And we can just pretty much close the enclosure, which has a snap-on lid. And now it's programmed, it's now time to test it out. And if we bend the flex sensor, the value changes, and this is sent to the robotic arm. So how well does the robot arm respond to hand gestures? Well, the prototype is pretty responsive and works. However, the robot glove is pretty sensitive, as it had quite a few sensors. Plus, it was a bit of a learning curve to control the robot without triggering other parts of the arm. But the good thing is, these are programming related, and improving the code should improve the accuracy and the fluidity of the arm. We'll revise this prototype sometime in the future, and I'll probably call it Mark 2. Hey, you've made it to the end, or you skipped ahead. Either way, thanks for watching. By the way, I've also recently started a Patreon, and if you would like to support the projects, that's the best way to do it. So thanks for that.
And thank you for all the subscribers. I really do appreciate it. Honestly, it's crazy. And thank you to everybody who subscribed. I literally reply to every comment, so please let me know if you do have any questions. And if you want to make a project like this and you want to improve on the code, definitely contribute to the Git repo. And you can find more details in the article below. I'm Evan. Thanks for watching. Peace.